Dear student, this is lecture 11. I have already sent you lecture 10. That was also correlation diagram. Now today I will talk about the correlation diagram of D1. Later on we will do correlation diagram of D2. What is correlation diagram? To begin with, let me say you are familiar with metal complexes. In metal complexes, as the strength of ligand field increases, the magnitude of delta octahedral, it also increases. Delta octa, naturally, if it is an octahedral complex, delta octahedral, this information, as we increase the ligand field, splitting increases. This information, it can be summarized in diagrams called correlation diagram. Now see below. This is a state doublet D. It comes from D1 system. Now as I increase the ligand field, what is happening? This delta octahedral, that is increasing. This is the whole thing. Just in after a few minutes, I will be explaining that we take the weak field, states on left side, and strong field. Now this is the strong field side on right hand side, and we connect them with line. That is the concept of the correlation diagram. Thus, I have written here, thus an energy level correlation diagram can be drawn showing energy states arising from weak field linked with energy states arising from strong field. Take example of D1. D1 system, I have put the configuration here. D1, of course, it is the simplest one, and there should be no interelectronic repulsions in it. So we will, when we put D1 in octahedral field, we will get T2G, low energy, and EG, high energy. Now here is one important thing which you should know, that in D1 case, we have this 1s2, 2s2, all these are completely full, and we ignore that. We simply consider 3D1. Why we ignore that? Please come here. As I have explained before, the totally filled occupied orbitals, they are totally symmetric. That is, that they have the highest symmetry. We call that A1. Have all the characters equal to 1, 1, 1, 1 of the group. So orbital degeneracy of this state is 1. A is equal to 1. You just remember. So A1 multiplied by B1 should be considered as 1 multiplied by B1, and that will be equal to B1. A1 multiplied by EG, again 1 multiplied by EG, and so on and so forth. So wherever you see A, it means totally symmetric. So S2 is totally symmetric. S2, P6 totally symmetric, totally symmetric, totally symmetric, totally symmetric, not totally symmetric. So this is what I mean by that. D1 system correlation. So the ground state, lower energy configuration is T2G1. Excited state is this. So in weak field, this gives D, doublet D. You know this. This is the ground state term. Okay, you already know it well. Now please, T2G1. Okay, we write it like this as well. Since it's one electron, so it will be doublet T2G. T is the same, T2G, same T2G. Up there, doublet. So EG1, okay, one electron, doublet. So it is doublet EG term. Orbital degeneracy of T is, it is triply degenerate, three orbitals, same energy, 3. EG is doubly degenerate, 2. So write the, so 3 plus 2 is equal to 5, which is same thing as D. D is, you know that, it's, I have written it, 3, okay, plus EG equal to, which is equal to the orbital degeneracy. This is very important point. Okay, now again, now here it is all very simple. In weak field, this gives this, okay, so D term in the octahedral field will split up and give rise to this and this. Yeah. D2 term gives rise to this. In strong field, what will happen? Delta octahedral is very large, so this T2G1 will remain T2G1 and it will give rise to this one, T2G2. EG will give rise to doublet EG here. Okay, so making correlation diagram, this is the terms which you are getting from the low field, D2, this, and this is the from EG, T2G1 and EG. This gives EG doublet, this gives this, and that's it. And then we connect that, and this is all explained. Very easy. Weak field states, strong field state. These are strong field states coming from this and coming from this. Now please note I have written this and this. This I will explain later on. So D1 correlation diagram, notice T2G4 and EG4. It's written here. Okay, right in front of T2G1 and T2G3 and EG3 in front of this. So the question is why we write this, okay, in front of this. This gives this. Does this also gives this? The answer is yes. This gives this. Does this gives this? The answer is yes. I will explain it. Okay, same way, this T2G3 and EG3 is written in front of configuration. This I have explained it. Question is why. Both questions will be answered later on in this lecture. Okay, D1 correlation diagram shows only one transition from this to this. Okay, there is no other transition possible, so that we expect only one absorption band. So this is the titanium water solution. So dear students, it's important that you study and understand the given below extra study material I have made. It will help you understand future lecture material, correlation diagrams of D2, D3, D10 and other things. Now this is the additional material which, and I would like that you try to understand it with concentration. And this is half filled orbitals, okay, p orbital or d half filled, okay. So all completely full and half filled orbitals are represented with it. Remember what is A? A is one dimensional. Okay, A means one. Okay, so all of these configurations, they can be represented with, they are represented with a totally symmetric. So the half-filled orbital, this will also a symbol A can be used for this. T2G6 is totally full and T2G3 is half-filled. This is also half-filled, so this is represented with A. Similarly, these are full, completely full orbital, completely filled orbital. They are also represented simple. So will completely filled orbitals are represented. Also note that symbol A is just like digit 1, as I have said it, like identity operation. This is in group theory. Identity operation is represented with A. It is operation of doing nothing. Okay? It's not operation of rotating this, that. It's just nothing. So this is A, I have written 1. 2 multiplied by A is equal to 2. 3 multiplied by A is equal to 3. Similarly, T2G product. Okay? Direct product A is equal to T2G, E is equal, e.g. D1 multiplied by K is equal to D1, and similarly like this. Remember, this is again very important. Okay, I have mentioned about this before as well. This S, P, D, F, which are terms, okay, they are called spectroscopic symbols for terms, not group theory symbol. These are group theory. Remember A, okay, it comes from group theory. B also, E and T, triply degenerate, T2, G, U, etc. Okay, now let us come to the question why, okay, T2G1, okay, can be represented with this. See this one now, very easy. T2G1 is equivalent to this. We are taking it for granted now. So T2G4 and EG2 originates from D6. Naturally, 4 plus 2, it is 6. T2G1 also, it originates from D1 configuration. This configuration, this is given by this. So D1 and D6 are equivalent because D6 can be represented as D5 plus 1 and D5 plus 1 can be represented equal to D5 plus D1 case. Now, see this one, this is half filled. So this is A. Okay, so A plus D1 should be equal to D1. So this is what I am saying. D5 is highest filled, so represented by A. So D6 equal to this, A plus D1 equal to D1. Done. Okay, so D5, which is half filled, can be represented with A. So we come to this conclusion. D6 is equal to D6, 5 plus 1 is equal to D5 plus 1 means D5 half filled A plus D1 equal to D1. We therefore can safely say D6 is equivalent to D1. This comes from this comes from D1. So that is what we are saying, that this should be equivalent to this because D6 is equivalent to D. We proved it. Note also that D1 and D6 give the same term. You can see that D1, double D. This is 4 unpaired, it's a double D. The next same way we will prove the T2G. This is written in the front of this. Why this is written there, I will prove that on next page. Okay. page 8, I have revised that, the one which I sent you before, to make it more clear. So I think now you will understand this whole material very quickly. See this, why EG1 is represented with this question, or EG1 is represented with this एक ही बात है. Okay, answer T2G, this orientation, it originates from D6, 3 plus D. This is a D6 system. And this also T2G1, it comes from D1. This is D1 and D6 are equivalent. This is proved before on page 7, just one page before. Okay, they are equivalent. So that means D6, I can write it like this, and then like this, D3 and D3, and then T3, I can write T2G3 plus EG3, again it is D6. Okay, this is equation 1. Now equation 2, T2G3, okay, plus EG3 written here is equal to T2G3 plus EG2 plus EG1. See, T2G3, I have split this into half, 2 and 1, EG2 and EG1 equal to this one. Now T2G3 and EG2 both are half filled. See this one, half filled T2G. See, this is half filled. Okay, so they are half filled, therefore it is A. And I even don't have to explain to you, you can understand it yourself. Okay, this is A plus EG1 is equal to EG1. So this is proved like this. Remember, term sequence is the same order for Dn octahedral and Dn plus 5, means whatever is the states which will come from Dn, same will come from this one. Here is an example. D1 is equivalent to D6, 5n plus 1. Okay, D3 is equivalent to this one. Add 5 into it, you get this. D2, add 5 into it, you get this. Add 5 into it, you get this. So these are all equivalent diagram. So example is D1 and D6. D1 strong field corresponds, okay, with correlation. You can see on page 4, it's already given, and I think I don't need to explain this. Configuration T12 is represented with this. I have already get. I have that this EG is represented with this. Further, also note that T2G is equivalent to this. T2G has 2 unpaired electrons. This has 2 holes in it. So electrons, and this is a positron, opposite of that. So if one give octahedral splitting T2G lower energy, the other will give tetrahedral splitting, okay, in EG, lower in energy, up energy and lower energy. And finally, this is, I think, will explain it. Term D1 is, okay, this is 10 minus 1 is